All right. Now that we're recording, those of you watching at home, write down the Earth and the watery planet here. You're only going to be taking notes on the phrases and words and sentences that I ask you to. You don't have to write everything down. Your quiz tomorrow will be based on that material. So here we go. And advance. Now. There we go. Okay. So from this slide, you want to write down the middle bullet point. You don't need these two things down here, just the middle bullet point. As you write that down, I'm going to be passing out the handout for this section. These handouts that you get for each place that we visit will make up the material that you need to study for the semester. So make sure you don't lose it. Generally, the handouts are things where there's too many words for me to ask you to write them down. Of course, we do have to get through the whole PowerPoint by the end of the hour. So, if that means that maybe you don't finish writing something down, these PowerPoints are available on Schoology. So if you miss something, feel free to go on there and fix whatever you need to fix, or just get the notes from a friend. So Earth comes from the Old English and German word for ground. That's the ground. You should know that 71% of the surface of the Earth is water. Go ahead and write this down. That's a lot of water. Some other water features, you don't need to write these down, are oceanic trenches. We've got some submarine canyons. Submarine canyons were produced as the floodwater runoff came off the continents. You can see it would have, because it was such a massive amount of water, it cut a huge canyon. And these canyons are much larger than the Grand Canyon, and you can't see them. They exist off the coast of several different continents. Oceanic plateaus are in some places. Abyssal plains, these cover more than 50% of the Earth's surface, so write this slide down too. For later. So, abyssal plains are pretty much the ocean version of the Great Plains. If you've ever had a car ride through Iowa or somewhere near the middle of our country, you know that the Great Plains is basically a lot of flat land. Abyssal plains are the same thing, except it's on the ocean floor. And this covers over half of our planet, this single surface feature. Ooh, you want to write this down. Mariana Trench, this is the deepest part of our ocean, almost 7 miles down. I do my best not to talk while you guys are taking notes, because when I was in college, a lot of times they would have all the notes up, and it would just be like full of words, and they'd be talking about it and explaining it at the same time we were supposed to write it down. So then it's like I'm either taking notes or I'm listening to you. I can't do both at once. So that's why there's that silence as you guys are writing the notes down. So the cool thing about this background picture, this is actually a three-dimensional image of the Mariana Trench. This down here is that area. So it's not like, it's almost 7 miles down for a long area. It's just a small trench that goes down that far. Still very deep waters outside of that particular area, though. And you can see here, it lies just off the coast of a certain country. What country does it lie off the coast of? Yeah, Japan's probably the closest. So go ahead and also write down that it is off the coast of Japan. You don't need to do this one. Again, I'll let you know what you need to write down. But the largest submarine canyon, those things that look like the Grand Canyon except they're underwater, is off the coast of the Congo in Africa. And that canyon is 500 miles long, 3,900 feet deep. So it is a massive, massive canyon. And if we could drain the whole oceans, it would be a really cool tourist attraction. And just for reference, 1 mile is about 5,200 feet. So it's almost a mile deep. All right, so just a little bit about where this is all coming from. I didn't have a textbook that I was looking at while I'm making this. I just figured, if we're talking about Earth, we all live here. It'd be kind of cool to just come up with stuff that I thought was interesting. So everything in this PowerPoint, and really the other PowerPoints too, is just things that I thought were interesting about each planet or star, and that includes the Earth. So this is the evaporation and water recycling process that you've all seen at some point or other in a science class. Water is in the ocean, it evaporates, goes and makes clouds, eventually it rains somewhere, and that runoff goes into other rivers, sometimes it'll go into groundwater. But eventually, the end of the story is that it's all going to find its way back into the oceans, and the whole thing starts all over again. So it's this continual recycling of that water. Write this one down. 29% of our surface is land. And if you have questions or comments as we go along, feel free to share. You don't need to write any of these down, but some of the land features that you've seen in a geography class or something along in your science classes would be plains, nice little flat surfaces there. Ice sheets, this is a big land feature, especially the further north you go. Deserts, as we saw on planet Earth. We got some forests, Mountains, that's a cool picture. We can look at that for a little bit. What's that? I wonder how cold this water is. You want to dive in there? You guys ever been swimming in Lake Michigan?
Yeah.
That is cold.
I went to Dark County. We jumped in. There was like this cliff diving spot, and we jumped in, and the water was like 40 degrees.
Right. It's freezing. It's sick how cold it is. A couple, not this last summer, but the one before. I like to, from where I live, if you go straight east, you get to Grant Park. If any of you are familiar with that park, and they have some cool little beaches there. And so 2 summers ago, when it got super hot on those days, the one day where it was like 105 or something, I went in the water and I was swimming around, and it was like I was swimming just fine, but you could tell my body was like, you really got to get out of the water now. But it was strange because I've been there several times before, and I could just swim around as long as I wanted to. Thought it was interesting that on the hottest day of the summer, the water was cold enough that I couldn't stay in it. All right, plateaus. You know what those are. Looks like that. Oh, this is kind of fun. Highest point above sea level. Write this one down. You don't need to write down the numbers. One of the things about the notes you take is, like, I would never say, what's the highest point above sea level? 5.5 miles, 5.6 miles, or 5.7 miles? If I would include numbers, it would be like 5 miles, 10 miles, 50 miles, numbers that are much larger. But in general, I don't really do a whole lot with numbers on these quizzes, with a couple exceptions. If I do have you write the number down, you should know it. So yeah, Mount Everest is the highest point above sea level, and this is the top of Mount Everest. At least that's what Google Images came up with. However, this is the closest point to outer space on Earth. You can write this one down too. And again, you can ignore the number of miles there. Wait, this one? My guess would be Chimborazo. Is that right? Close enough. And what is the proper pronunciation? Someone tell me? Ah, okay. So the question kind of becomes, if Everest is the highest, mountain, how can this be the closest point to outer space? Any guesses on that? Yes, Josh. That's exactly correct. So, Earth is mostly a circle, it's mostly a sphere, but it's not perfect. And so, when the Earth spins, you guys ever gone through like a puddle on your bikes and it kicks up the water and it gets on your back and stuff? So the reason for that is because the wheel is spinning so fast that the edges are moving so much faster than the other parts, it can't help but throw the water off from those edges. Well, when the Earth is spinning, it's actually spinning quite fast. And so one of the results of that is the Earth is actually a little bit flatter, and at the poles, so it's kind of bulging a little bit like this. It's not quite like this if you look at the Earth. It'd be really hard to tell just from a picture. But this is essentially what's happening. So the poles on the Earth are closer to the center of the Earth than the equator. So spots on the equator are further away from the center of the Earth than places up here in the north, like Mount Everest. So if you define the closest point to outer space being the point furthest away from the middle of the Earth, you would get Mount Chimborazo. Is that a little bit better? So yeah, that's why that's the closest point to outer space, because the Earth is bulged a little bit, like Josh said. Largest rainforest in the world is in Brazil. You can skip this one. But it's 68% the size of the United States, so that's a pretty big forest. Largest desert in the world would be the Sahara. I'll say, just write down that the Sahara Desert is the largest desert in the world. Again, you don't need to write down the number. Anybody else have the urge just like kick your shoes off and run to the top of one of these hills? Must just be me. All right. The Antarctic ice sheet is the biggest ice sheet in the world. You can skip this one too, but it is about 3 times the size of the United States. So, yeah, when you hear how big this is, when you hear the Antarctic ice sheet, it is massive. It is just enormous. So 3 times the size of the continental U.S. Of course, that means the United States without Alaska and Hawaii included. And a little bit about geography. Here's what the world looks like if you flatten it out onto a map. You've got your different continents right here. And those continents are actually moving with respect to each other. And that's what these arrows indicate. You can see on the western end of North America, it's impacting the Pacific plate. And, of course, you probably know that along the west coast of America, they have a lot of earthquakes. The reason for that is because you've got 2 plates interacting in that area. Anywhere you've got these 2 plates interacting, you're going to have earthquakes occurring. The super destructive tsunami that happened in 2004 on Christmas Day that killed hundreds of thousands of people originated right about here. It was a lot of people in Indonesia here that ended up losing their lives from that. And this is how plate tectonics works in a quick picture. So you got the plates moving. One's going to go underneath. And because it's going to go underneath, you've got 2 things happening. That material will eventually melt, bubble up, and eventually it's going to find its way to the surface through volcanoes and mountains. Those mountains also occur because you've got it going down, and that actually pushes up the material too. So it's not just the magma that's coming up. It's the actual rock material itself that's being forced up as this displaces that material as it goes down. So that's kind of what's happening. I'm guessing you don't need to write this down, but you should know that. 24 hours for the Earth to go around once, orbits the Sun every 365 days. That is a year, unless it's a leap year. In all the planets that we look at, there will be a slide that is something like this. You don't have to write any of these numbers down, but I do kind of want to get you a little familiar with some of the terminology. AU is an astronomical unit. So when we visit other planets, we measure those oftentimes in these astronomical units. 1 astronomical unit is 1 Earth to Sun distance. So that's where that comes from. Earth is moving in orbit around the Sun at almost 20 miles per second. This is not miles per hour. This is 20 miles per second. So we are zooming through space very, very quickly. You can write this one down. If this was on the quiz, it would be like, how big is the Earth? Is it 8,000 miles, 15,000 miles, 20,000 miles? So the numbers would be much different from each other. Alright.
I taught him a lot.
I'm sure you did.
You get back in the recording.
You don't have to write this down, but one thing that we do look at on all our planets is the average density of it. We don't really have to think about what this number actually means. If this number was 1, that is the density of water. So it kind of gives you an idea that if we overall take all of Earth, all the material on the surface and underneath, and you average it all out, the average density is much higher than water, even though water covers a vast majority of the surface. Probably don't need to write this one down either, but we got all sorts of different seasons here depending on your latitude. Personally, I really like living in Wisconsin because I like getting all of the seasons very defined. I love summer. It's my favorite season, but if I had it all the time, I would totally take it for granted. So let's just see a show of hands here. How many people, your favorite season is winter? 1, 2, 3, 4. How many people, favorite season, autumn? 1, 2, 3, 4, 5, 6. Favorite season is the summer. Pretty even here so far. And springtime. A lot of people like spring. Yeah. The only thing I don't like about spring is by the time spring comes along, you're like done with the cold weather, you know? And spring, to me, is like just a big practical joke. It gets warm for a little while, and it's like, oh, snow during prom, you know? So, all right. Your hottest temperature ever recorded on Earth is important, so write this down. 136 degrees Fahrenheit. That happened in Libya.
When was this?
I don't know. I'd have to look. I suppose I haven't checked to see if this is updated. This was the hottest temperature when I started teaching this class.
Wow.
Maybe it's gotten hotter.
137.
And actually, this isn't, I mean, that one summer, we had temperatures that were in the hundreds.
I was going to do it right now.
So, yeah, I might have to update it. We'll see.
Yeah.
Any guesses? Oh, it's still the same? Cool. Any guesses on what the coldest temperature was? Negative 100 I'm hearing. I heard negative 70. Any other guesses? Negative 82. The coldest temperature ever recorded on Earth is negative 129 degrees Fahrenheit. You would freeze like instantly. This guy is probably frozen in that spot. It's a Yeti. You turn into a statue awfully fast. Of course, that's Antarctica. Another thing that we look at on Earth and with all the other planets is whether or not there's an atmosphere and what qualities that atmosphere has. Earth has a moderate atmosphere when compared with those of other planets. You can probably at least remember some of this stuff from previous science classes. Our atmosphere is mostly nitrogen, good amount of oxygen obviously, but mostly it's nitrogen out there. We've got all sorts of different types of climates. We've got all sorts of different kinds of weather. So for me, I was kind of interested in what were some of the extremes in terms of this weather. So in case you're not sure how weather works, if it's just like say you're outside and it's kind of a steady rain and it's a little warm outside, this is probably what's happening. You had a cold air mass that was in that one spot, and some warm air came in, and because warm air rises, it goes above the cold air, And as it rises, it cools, and then it falls as rain because it's condensing. If you've got a really severe thunderstorm, something that's a little bit more serious, usually that starts where it was warm, and then a cold front moves in very quickly. This warm air rises very fast, and because it's rising so quickly, it cools very quickly, and it falls as very heavy rain and storms. Now, in terms of the most powerful storms we've ever seen, any guesses on the biggest, baddest tornado that was ever recorded? Yeah.
I don't know.
Happened a long time ago. You probably have never heard of it.
The one in
It was called the Tri-State Tornado. It happened in 1925. I would like you from this slide to write down Tri-State Tornado, 219 miles, and write down the 3 states that it traveled through. Write down Tri-State Tornado, 1925. You might want to write the title down too. Most powerful tornado ever. Write down how far it went, and then the states that it passed through. So there was a continuous path of destruction going from Missouri through Illinois to Indiana. This is the longest path of destruction ever recorded by a single tornado. It was described as an amorphous rolling fog. Other people said it looked like boiling clouds on the ground. Nothing quite like it has been seen since. Wind speeds that were sustained at 300 miles an hour. I mean, that's like half the speed of sound. It was insane how powerful this tornado was. So when they say those descriptions, these are just some more modern tornadoes. Might give you an idea of what it would have looked like. These were not as big as that one. But you can kind of see where they get the idea of it looking like a rolling fog. Yeah, you don't want to get in the way of these. And this is the newspaper article not long after it happened. It was unannounced. It happened late at night. It was not a pretty sight. So, if that's the most powerful tornado, what do you suppose we got to talk about next? The most powerful hurricane ever. This is literally going to blow you away. Ha 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 ha. Pun intended. Go ahead and write down hurricane tip. And write down the sustained winds and the maximum winds. An easy way to kind of remember hurricane wind numbers is that they're less than tornado wind numbers. So if the tornado is 300 miles an hour, you know that if this is on the test, it's got to be less than that. And honestly, I would probably say, if this was on the quiz, I would say 100, 200, or 300 miles an hour, you know? So this is a picture of that hurricane from the satellite image. You can't really tell how big it is because there's nothing to compare it to. At this point is when it was at its biggest. So it did not impact land when it was at its most powerful. It weakened quite a bit before it dropped a whole bunch of rain on Japan. But just to give you an idea of how big this hurricane was if it had impacted the United States. Yeah. Can you imagine what that would do? Yeah. Biggest hurricane ever right there.
Was it the most destructive or
No, it was not the most destructive because it weakened a lot before it hit land. But if it had hit land at its strongest, it would have been. So this is just a description on why the colors are why the sky is different colors. So if you want to read that through sometime, feel free. I'll tell you this isn't going to be on the quiz, but it is on your handout if you want to read it through at some point. It is really interesting. The reason that the sky is blue is because there's a certain molecule in our atmosphere that when the white light from the sun hits it, the specific blue wavelength colors hit that molecule and scatter everywhere. That's why the sky is blue. The sky is red and orange at sunset because those colors have a longer wavelength, and those wavelengths, because they're longer, can more easily pass through our atmosphere. That's why we see those colors at sunset and sunrise. Long wavelengths are much easier to see in general. A nice little sunset there. One of the things that we talk about in this with regard to Earth and other planets is whether or not they have any geological activity. Earth is active. We've got volcanoes that are erupting on a regular basis. A little bit about Earth's composition. We've got the crust, the mantle, the outer core, and the inner core. Generally, it gets less solid the deeper you go. Viscous means it's thick, but it's not solid. It's kind of like really tough to move Play-Doh or silly putty or something. Earth has a magnetic field, and that's a good thing, because if we didn't have one, we'd all be dead. The reason for that is because the sun shoots out all sorts of harmful radiation. We've got a magnetic field, and that deflects all that solar radiation around us. It kind of does a little bit. So, now it doesn't deflect all of that radiation around us. A little bit does get through, because there's a part in the Earth's magnetic field that separates from north to south pole. And that's represented right here. So polar cusp is what it says there. And so when some of those particles make it through to the Earth's atmosphere, what do you suppose happens? Nope. Aurora, the northern lights. The northern lights occur because of the magnetic field on Earth funneling a small portion of those radiative particles to our atmosphere. The brightening of the particles happens because of the way that they interact with the molecules in our atmosphere. This is on your handout. I would like you to put a little star or an arrow next to the second bullet point. Know the second bullet point. Yeah. Everything I'm having you write down or put a little arrow next to is fair game for the quiz. And just to make sure you're not worrying, I'm looking at the quiz now, I see one question that has a number in it. So it's not like there's 5 questions that you got to make sure you memorize all these numbers. It's a type of quiz where everything on it is not tricky and not, it's not meant to be something where I'm picking out a small part of a phrase and trying to, trip you up on it. It's all pretty big picture stuff. Some pictures of Aurora there. Pretty, pretty, pretty. We don't see these too often at our latitude. You generally have to be further north than Wisconsin, but they occasionally will show up. I sure have a lot of these, don't I? This is what it looks like from space. One of the other things that we talk about on all these planets is whether or not they look old, like the billions of years Big Bang timescale says, or whether they look young. Everything that we look at looks young. And as far as Earth goes, this is the one thing that I picked from a ton that I could say about why the Earth looks young and not old. Go ahead and write this down. So yeah, the Earth's magnetic field and the rate at which we observe it decaying is perfectly consistent with the time scale of the Bible, where the Bible says the Earth is roughly 6,000 years old. It's totally inconsistent with millions or billions of years, because if it was decaying and getting weaker for that period of time, it would have been so strong that long ago that the Earth would have literally burst into flames. So, interesting stuff. And the last thing I want you to write down is coming up next. You don't have to write this down, but we actually have two moons. There's the big white one we're familiar with. And then there's this one. It's very small. You'll never see it because it's that small. But we do have a second moon. Maybe that'll come in handy during a trivia game. But for all the planets, I actually made awards. And Earth gets first place for these things. Write this down. You need to know all three.
Well, did you ever talk about Pluto?
Oh yeah, Pluto's my favorite planet. That's one of the things we talk about, is we talk about whether you believe Pluto should be a planet. So it's pretty fun. And for the record, Earth comes in second place for a few things. You don't have to write any of these down, but second strongest magnetic field in the solar system. Quiz on the Earth, 10 questions coming at you tomorrow. Be ready when you get to
Yes,
class.
sir. I was born ready.